All right, today we're doing something really interesting. We're going to put the world's most powerful AIs through the ultimate memory test. In this test, it's designed to answer a question that sounds simple, but, well, it gets right to the very heart of what AI can really do.
And the question is this: can an AI read an entire book and remember a single sentence? I mean, it sounds easy, right? You'd think if an AI can swallow a whole library of information, remembering one tiny detail would be a piece of cake. Well, that's exactly what researchers wanted to find out. And let me tell you, the results, they're not what you'd expect.
So, you see, the top AI models out there now claim to have these massive context windows. We're talking over 1 million tokens. Now, to put that into perspective, 1 million tokens is roughly the entire Lord of the Rings trilogy. So the AI companies are basically telling us their models can hold all 3 books in their short-term memory at once. That is an incredible claim.
But, and this is the big but, this is where they fail. So, what happens when you actually push these models to their breaking point? Well, it turns out there's a pretty massive gap between what's on the box and what's actually happening inside. Let's dig in and find out why.
And that brings us to our first big idea here, what we're calling the long context illusion. It's this idea that maybe, just maybe, these giant memory capacities aren't quite as solid as they look, especially when you really put them to the test.
So that begs the question, right? How do you actually test if an AI's memory is as good as the marketing says? You can't just, have a chat with it and see. No, you need something systematic, something repeatable, and honestly something incredibly difficult that can really separate the hype from the reality.
Okay, so to do just that, to separate that hype from reality, a team of researchers decided to build the ultimate test. They created this brand new benchmark, a challenge designed for one reason and one reason only: to find the absolute breaking point of an AI's memory.
And that test has a name: Babylon. Its mission sounds pretty simple on the surface. Can an AI find and then use a specific, crucial fact that's been deliberately buried inside an absolute ocean of unrelated text?
The whole setup is actually kind of brilliant in its simplicity. You've got 2 main parts. First, the needle. This comes from a dataset called Bobby, which is just a collection of simple, crucial facts. Then you need a haystack. For that, the researchers grabbed thousands and thousands of pages of text from classic books, all of it totally irrelevant.
So, you have your needle, you have your haystack. How do you turn that into a real test? Well, this is where we get to see the real genius of the Babylon benchmark in action. We're talking about creating needles in digital haystacks.
So let's take an example. The test starts with a simple, undeniable fact: the needle. Something like, Mary traveled to the office. This one little sentence is the crucial piece of information that the AI absolutely has to find and remember.
But here's the kicker. That single sentence, it's buried, completely at random, somewhere inside a document that could be millions of words long. It's really the ultimate test of an AI's focus and its ability to recall information.
Okay, so after the AI has read this entire massive document, it gets asked a really simple question. Something like, where is Mary? Now, you can only answer that question if you found and understood that one hidden sentence. If you found the needle, the answer is the office. Super easy. If you didn't, well, it's literally impossible to answer.
But wait, it gets even more clever. Babylon isn't just one test, it's actually 20 different kinds of reasoning challenges. For example, some tasks just need one supporting fact, like our Mary example. Others need the AI to connect 2 different facts hidden in the text. There are even tasks for counting things or understanding negative statements. It's a full-on cognitive workout for these models.
So this is the moment of truth, right? How did the world's most powerful AIs actually perform? I mean, with their 1 million token context windows, you'd think this would be a walk in the park, right? Well, the results were not what you'd expect. Honestly, they were fascinating, but also kind of concerning, especially if you're someone who relies on these AIs to analyze really long, important documents. And here's the bombshell right from the research paper itself. Even the top models, the ones that claim they can handle 128,000 tokens or more, they started to experience degradation. They started failing. Once the text got beyond just 10% of their advertised capacity, they just started losing the needle in the haystack.
This chart just illustrates the problem perfectly. You've got this massive claimed memory. Let's call that 100%. But the actual, reliable, usable memory, at least under these stressful needle-in-a-haystack conditions, it's looking a lot more like just 10% of that. That's a huge difference. So what does all this mean for the future of AI? Well, it means the search continues. The challenge of creating true or reliable long-term memory in these models it's far from solved. But the good news is, results like these show us exactly where we need to focus our efforts. And look, this isn't just some abstract academic thing. Why does this matter? It matters because it reveals a really fundamental weakness in how current AIs handle information. They might be getting really good at seeing the whole haystack, but they're still struggling to remember every single needle that's hidden inside it.
The really great thing here, though, is that the creators of Babylon have basically thrown down the gauntlet. They've made this an open challenge for the entire AI community. They're saying, hey, test your own models, share your insights, help us improve the benchmark. It's all about pushing the technology forward together.
And all of this leaves us with one last, kinda heavy question to think about. If our most advanced AI today struggles with a single sentence buried in a book, what bigger things might it be missing? What other crucial details, what subtle nuances, what important truths might be slipping right through the cracks?